Okay, everyone. Welcome to our first day or pre-work on our next unit, which is on exponents. So what we're going to do for this pre-work is just do a little review. You probably have seen a lot of this stuff before, at least the first couple of items on our agenda, but we are going to just refresh our memories on what an exponent means and how do you write it, how do you condense and expand it, how you evaluate using exponents, and then we're going to start with the first two rules of exponents. So let's go over very quickly on your notes page. So you all have a notes page. What I'm going to do is I'm going to go over a few things with you, and you're going to fill in or answer the questions that I don't go over as part of your homework. So let's start with a few notes here that we're going to write down. So you're just going to follow along, write things down, like I said, and then you will end up doing the problems that I don't do. So an exponent. If you were to look up the definition of an exponent, you would see this sort of formula that they have for it, and it is they say x to the nth power. So in this formula, the base would be considered the number at the bottom or the bigger number. So x is our base, and then our power or our exponent is going to be the letter n. So we would say this as x to the nth power, or you could say x to the exponent of n. So that's just the basic kind of structure, skeleton of an exponent. And so let's look at an example and then what I might ask you to do with that example. So let's say we're going to talk about 6 to the fourth power, or 6 to the exponent of 4. So first, we're just going to identify what the base is. So the base would be the big number, which is the number 6. And then 6 is being taken to the power or the exponent of 4. So what does this really mean if I wanted you to actually solve this? So remember, in case you don't, that base times the exponent, it's not that you're multiplying 6 times 4. You are going to be multiplying 6 by itself 4 times. So if I were to ask you to expand it, you would write it out like this. You would write out 6 times 6 times 6 times 6. Now, I usually use the dots in between because sometimes you might have a variable that you have to expand, like an x. And so if you put an x in the middle, you might get yourself confused. So I put a dot. So if I were to ask you to expand, or what does 6 to the fourth actually mean? It means I'm taking 6 times itself 4 times. Then if you wanted to actually evaluate this and put it in your calculator, you could absolutely do 6 times 6 times 6 times 6. Or you could use this thing called a caret. If you can find that on your calculator, it looks like this. This is called a caret. You could go 6 caret and then the number 4, it hit equals. And so if you wanted to try that right now on your calculator, if you have it handy, try that and see if you get 1,296. Okay, so that is how you identify the base, the power, how you expand it, and then how you would evaluate in the calculator if that is what I had asked you to do. Now, I might give you something that is an actual variable. So I might give you something like this, 6x to the fourth power. So I want you to be very careful with this. What this means, your base here is not 6x. Your base is just the x, because the 6 is not being taken to the fourth power, just the x's. If I wanted 6 to be taken to the fourth power, I would write it like this. I would put 6x in parentheses, meaning that I'm going to do 6x times 6x times 6x times 6x. But I'm not doing that. Instead, what I'm doing is I am just taking x to the fourth power. So x is my base and my power is 4. But then what is 6? Is there a name for it? I'm not sure if you remember this from last year or from the past, but the 6 is actually called something, starts with the letter C. It's called a coefficient. So coefficient, which is a number in front of the variable. Let's see if I can spell it. Coefficient. Okay, so that's what that is. And so if you were to expand this, you would write 6 times x times x, 4 times is to the fourth power, times x times x. So this would be the expanded notation. And you can't evaluate that because we don't know what x is. So this would be how you would expand something that has a variable in it. So the rest of this page here is just you practicing going back and forth between condensing and expanding. So I'm just going to do 2 in each section, and then you're going to be responsible to finish the rest. Let me clear this out. Scroll up. All right, I'm just going to do 2 from each section. So let's try, let's go with A. So for A, all I need to do here, I'm going to condense it. So my base here is 4. And then how many 4s do I have? 1, 2, 3, 4, 5, 6. So that becomes my exponent. The number of times is 6, so that becomes my power. All right, let's try E, because E has 2 different things in it. We have 2 bases of 5 and Y. So we have a base of 5, and there's 2 5s, so it'll be 5 to the second power, and then a base of Y, and there are 5 Ys, 1, 2, 3, 4, 5. And so the power of 5. So 5 squared times y to the 5th. Okay, now expanding, if I want to expand, I'm just going to write it out like I showed you before. So let's try C here. So for C, I need to bring the negative with me. I also want to be very clear that there is a difference between putting -3 to the 5th power in your calculator versus parentheses -3 parentheses to the 5th power. These will give you 2 different answers if you were to evaluate them in your calculator. Because in this one, you are actually taking the negative to the 5th power. In this one, you are not. One has a negative, one does not. So just be very careful with that. So this one, we're going to do -3 times itself 5 times. So -3 times -3 times -3 times -3 and times -3, 5 times. Okay, let's do E then. So E is very similar to the E we did up here. So to do 3 squared, that's going to be 3 times 3, 2 times. And then x to the 5th would be x times x times x 5 times. All right. So this is a quick little, hopefully, review for you to refresh your memory on what exponents and bases mean and how you can condense and expand. Like, what does it actually mean to take something to that power? Okay, next section. So this is 1. We got 2 more things to do. The second section we're going to look at as a quick review is how we evaluate this. So let me clear this. And let's flip it over to the back of the first page. So there's 3 problems here. I'm just going to go over one with you and where we are evaluating. So we're going to plug these numbers in and evaluate. Now, you can absolutely use your calculator. However, I want you to do just like you did with the absolute value ones where we are showing our work. So then I can see where you're making mistakes. But you're more than welcome to use your calculator to help you along the way. So I'm going to go ahead and plug these in. My strong suggestion, I talked with you about this before, when you're plugging things in. So right now it's A, this means A 2 times A. So I'm going to go 2, I'm going to put a parenthesis here of 9 squared. Whenever you plug things in, put them in parentheses. It will be very helpful to you. So right now I'm plugging in B, plugging that in with a parenthesis. So this is what it would look like if I substitute my A and my B in as my 9 and -3. And again, when I'm putting it in, I'm putting them in parentheses when I'm plugging it in. So now order of operations state to do parentheses. Okay, so what we're going to do though by the parentheses is we're going to get this parenthesis down to 1 number before we divide by 4. Then if we look at these parentheses on the inside, some get confused and they try to do 2 times 9 and then square it. But remember the order of operations, exponents come before multiplying. There's a difference if it says this, 2 times 3 squared versus 2 times 3 squared. In this one, the 2 and the 3 are getting squared because they're in a parenthesis with the square. In this one, the only one getting squared is the 3, not the 2. So therefore, we cannot multiply here before we do our exponent. So we want to do our exponents next. So next I'm going to square my 9, which gives me 81. I'm going to keep that in parentheses and have the 2 on the outside. Minus 3, and then here's where you have to be so careful in your calculator. You need to put a parenthesis because if you plug this in your calculator, it is going to end up giving you a -9 as an answer because your calculator is not squaring the negative sign for you. But if you do this in your calculator and put a parenthesis around it, it is going to square the negative for you and give you the +9 that you should have as an answer. If you don't, you're going to get a negative and it's going to throw off your whole answer. So please, please, please use parentheses when you are squaring a negative. All right, now that we did our exponents, the next step is going to be to multiply. Multiply before you subtract. So 2 times 81 is going to give me 162. And then minus 3 times 9, which gives me 27. All right, then again, order of operations, our parentheses come next before we do our division. Remember, we're trying to get our parentheses down to one number. So 162 minus 27 is going to give me 135. 135 divided by 4 is going to give me a decimal. It will give me 33 3/4, or you can have 33.75 is also okay. Okay, so I'm going to give you, you're going to do C and D, or the second two by yourself for homework. I will give you a hint that neither one of them are a fraction or decimal. So you should get whole numbers for both of them. All right, so you can do that on your own. All right, let's move on to the last page, which we are going to start the rules of exponents. So there are a total of 5 different rules for exponents, and we're going to be practicing them for the next 2 days when we come to class. But I'm going to teach you the first 2 right now because they're one of the more easier ones to grasp. So we're going to do those as pre-work. So I'm going to start with 0 power. So the 0 power rule here states that anything taken to the 0 power is always 1. Now, why? Why is that? Let me give you a little exhibit. So let's pretend we're going to do the number 5. So let's say we're going to do 5 to the first power. So 5 to the first power, I'm going to write down here, is equal to 5, because 5, times, itself, well, whatever, we're just taking 5 by itself is just 5. Okay, now let's add an exponent. So let's do 5 squared. 5 squared, which is 5 times 5 is 25. All right, now, how about 5 to the third power? So 5 to the third power, we're doing 5 times 5 times 5 is 125. So I'm actually going to show you both rules right now. What about 5 to the 0? So 5 to the 0 would be over here, right? Because if we're going on a number line, 5, first, 5 second, 5 third, 5 0. Okay, so let's think to ourselves, how would I get from 125 to 25? What would I have to do? And it's not subtract 100. I know that makes sense, but what's the pattern? So what is the pattern from 125 to 25 and then 25 to 5? How did I get there? Yes, I know you could say I subtracted 100 and I subtracted 20, but I want it to be the same thing. So how do I get from 125 to 25? I would divide by 5, right? So if I divided 125 by 5, I would get 25. Okay, does that rule work for the next one? So if I do 25 divided by 5, am I going to get 5? Yep. Okay. So now what is 5 divided by 5? 5 divided by 5 is 1. So following this pattern shows and proves the rule that anything taken to the 0 power is always 1. Everything in the world that you could take to the 0 power. 175 billion trillion zillion to the 0 power is 1. X to the 0 power is 1. X, Y, Z in parentheses to the 0 power is 1. Anything to the 0 power is 1. So if we were to look at this sheet here, let me scroll up a little bit. We looked at this sheet. Anything you see to the 0 power is automatically 1. So just to give you a few examples here. K, X to the 0 power, answer 1. Right here, M, XZ to the 0 power, answer 1. Awesome. N right here, X squared times, that's times, Y to the 0 power. Y to the 0 power is just 1. Cancel that, make a 1. So your answer is just X squared. Okay, now I can't show you these ones down here with the zeros just yet because we need to understand what the negative exponent means. But the simple ones that are just to the 0 power, they are all 1. And like N and O, if there is a 0 in there, you just literally cancel it out. It's a 1, and your answer is whatever is left over. That's how you simplify anything to the 0 power. Super simple. All right, now let's talk about the negative exponents. That is the second rule here we're going to talk about. I'll explain what this means in a moment, but let's go back to my diagram that I made. And let's keep going backwards. So now what if, let's go here. So let's say, let's bring it on over here. So let's go 5 to the negative 1 power. So again, if I follow my pattern of dividing by 5, okay, so I did 5 divided by 5, got me my 1. Now, what is 1 divided by 5? I don't want a decimal. 1 divided by 5 is 1/5. Okay, 5 to the negative 2 power. I'm going to divide by 5 again. Okay, so if I do 1/5 divided by 5, which if you remember, good old-fashioned fraction rules, keep, change, flip, it's actually going to be 1/5 times, and then flip this to 1/5. So 1/5 times 1/5 is actually 1/25. So look what's happening. 5 to the first power is just the inverse of 5, or the reciprocal, I should say, of 5 to the negative first power. 5 squared is just the reciprocal of 5 to the negative 2. So that means 5 to the third power would just be the reciprocal. So 5 to the negative third power is 1/125. So that is where this rule comes in right here. So any negative exponent, what you're going to do in order to make it positive, in order to make it happy, is you're going to flip it to the bottom of the fraction. So for example, x to the negative 4th, in order to make it positive, you're going to flip it. So you're really going to say, okay, this is the same thing as 1/x to the 4th. Because here we showed that the negative exponent is just the reciprocal of that answer. And then notice how there's no longer a negative exponent by it. So what you do is you flip it and then you change it to a positive. That's the rule. So if you want to write that down, how do you simplify a negative exponent? You flip it and you change it to a positive. So for B, flip it. So be 1/y to the positive third power. Just flip it, make it happy. Okay, what am I going to do with E? They're both negative. One's on the top, one's on the bottom. So the x to the negative 2 shouldn't be at the top. It needs to be at the bottom. So we're going to flip the x squared to the bottom. Again, make it happy. Make it positive. Z to the negative 4th, it shouldn't be at the bottom. It should be at the top. So flip it, change it to a positive. So this is how you would simplify negative exponents. You literally just flip it and then make it positive. Let's look at G. Again, I'm skipping some on purpose because I want you to try them. So G, this is the only one that's unhappy. So y squared is going to stay at the top because it's already happy. It's not negative. But x to the 5th shouldn't be there. It should go to the bottom. and then we're going to change it to a positive. So when you're simplifying, what we're doing is we don't want any negative exponents. We want all of our negative exponents to be happy and to be positive. So in order to do that, we need to put it on the correct side of the fraction that it belongs. So on this one, on I, the only one that's negative is y to the -4th. So what do you think we're going to do? It should go to the top, right? So bring it up to the top. There's no more denominator, so your answer is just I to the 9th times y to the 4th. Okay, I'm going to go ahead and clear this off so I can show you a few at the bottom here. Okay, let's look at ones that now have multiple things in it. So let's just take a look at R. So if we look at R, we have both rules that are in here. So first rule, we all know that anything to the 0 power is just a 1. So z to the 0 power can cancel out and just be a 1. We're done with that. Now we got to deal with the negatives. Negatives are not happy on the top of the fraction. So in order for them to work properly, they need to move to the bottom of the fraction. So what will be left on the top? It's not 0. There's always an imaginary 1. Okay, so imaginary 1 gets left. We're going to move the x to the 5th to the bottom and the y squared, change them to a positive, and that's our answer. So this is how we simplify. Okay, so rules are: 1, simplify by making 0 a 1, and then simplify by changing the negatives to a positives by changing them on either side of the fraction. Okay, so if one is positive, change it to a positive. If one is negative, change it to a, if it's negative, change it to either side of the fraction, and then you change it to a positive. Okay, so finish up the rest that you have that we did not do, and then we will go over a few things when we get back. The last thing that we're going to do is I would like you to turn to the back, and we are going to do one more problem that has to deal with multiple things, like having coefficients, because I haven't talked about having coefficients. So just one more example I want to show you, and then I'm going to give you one to try on your own on the back of this sheet. All right, so just one more. So this is going to be putting multiple things together, but we have coefficients this time. So I'm going to give this one. So we're going to go 3h squared j to the -5th over 12 d to the 0 and f to the -4th. Okay, the only thing different about this example compared to what we did on the front of this page is that there are coefficients now. We have a 3 and a 12. So what we do with coefficients is we simplify them. We divide them out, pretend that they're a fraction. So let's just pretend this is 3/12. All we need to do is simplify this. So 3 and 12, we can divide each of them by 3. So I'm going to divide the top and the bottom by 3, which is going to give me 1/4. Okay, now we're going to deal with each piece one by one. So h squared, I'm looking at it. There's not a negative and there's not a 0. So it is fine where it's at. We're going to keep h squared at the top. Okay, next one. Let's look at j to the -5th. J to the -5th is negative. It's not happy, so it means I need to move it to the bottom where it will be happy. So j to the 5th is going to come down to the bottom and change it to a positive. Next, I'm going to look at d to the 0 power. So d to the 0 power, remember the rule is that it is equal to 1. So literally you can just cancel it out. It's a 1. 1 times whatever is just there. So you can just really ignore it, cancel it, move on with your life. Last thing here is f to the -4th. It's a negative, means it's not happy. It's not where it belongs. It belongs at the top of the fraction. So we're going to move the f to the top of the fraction and change it to a +4. So this is your simplified version of this expression, making sure there are no zeros and no negatives. You don't have to list this 1 here. It can just be as h squared f to the 4th over 4j to the 5th. So here's your practice problem that I want you to write on the back of your notes page, and you are going to simplify this one on your own for homework. So it's going to be 20a to the negative 3rd, b to the 0, c to the 5th, all over 16 d to the negative 3rd, e to the 4th, f to the 0, and g to the negative 5th. So remember, hints on this. First step, simplify the fraction, the coefficients, and then take letter by letter, what do I do with it? Is it a 0? Can I cancel it out to a 1? If it's positive, keep it where it's at. If it's negative, I need to change it to either side and to a positive. All right, that is it. Good luck. Let me know if you have any questions.